So here for part A, we can take the torque on the right end in order to find a relationship for the force of friction. So this would be equal to 0 because there's rotational equilibrium, and this would be the force of friction times the length minus the weight times the length over 2. And we find that the force of friction is simply going to be equal to the weight divided by 2. At this point, we can take the sum of the torques on the at the point where the cord is attached. So this would be equal to the normal force times tangent theta L minus the weight times L over 2. And we know that tangent of theta will be equal to the weight over 2 divided by n. So this would be equal to the force of friction divided by n, which would again be equal to the coefficient of static friction, given that the force of friction is going to be equal to the normal force times the coefficient of static friction. So we can say that the tangent of theta equals the coefficient of static friction, which means that the angle simply equals arctan of the coefficient of static friction. So arctan of 0.40 equaling 22 degrees, and this is the maximum angle measure. For part B, now we have a torque acting on the stick and the cord, so we can say that the force of friction times the length equals the weight times the length over 2 plus the weight times the length minus x. We also know that the normal force times the length times tangent of theta is going to be equal to the weight times the length over 2 plus the weight times x. So we can say that we also know that the coefficient of static friction equals the force of friction divided by the normal force, which means that the coefficient of static friction would be equal to the weight times L over 2 plus the weight times L minus x. This would be divided by the weight times L over 2 plus the weight times x, and then this would be multiplied by tangent of theta. So we can actually solve and say mu s is going to be equal to, once we cancel out all the weights, we find that the coefficient of static friction would be equal to 3L minus 2x divided by L plus 2x, again, times tangent of theta. And we can say that L plus 2x divided by 3L minus 2x will be equal to tangent of theta divided by the coefficient of static friction. We can solve, we can say that 3L minus 2x times the tangent of theta would be equal to L plus 2x times the coefficient of static friction. And so we can say that L times 3 tangent of theta minus the coefficient of static friction would be equal to 2x times the tangent of theta plus the coefficient of static friction. And then we can say that x is simply going to be equal to L over 2 times 3 tangent of theta minus the coefficient of static friction. This would be divided by tangent of theta plus the coefficient of static friction. And at this point we can solve. So x is going to equal 1 over 2 times 3 tangent of 15 degrees minus 0.4. And then this would be divided by tangent of 15 degrees plus 0.4. And we find that x is going to be equal to 0.302 meters. So this would be your final answer for part B. Now for part C, they're stating that x equals 0.1 meters. So now what is the coefficient of static friction? So the coefficient of static friction would still be equal to 3L plus 2x divided by L plus 2x. This is from part B times the tangent of theta. And so this is going to be equal to 3 times 1 plus 2 times 0.1 divided by 1 plus 2 times 0.1. And again, times tangent of 15 degrees. We find that the new coefficient of static friction is 0.625. So this would be your answer for part C. That is the end of the solution. Thank you for watching.